Some tractors plowed straight furrows and faded into memory. Others broke every rule and became legends. Today, we're counting down 12 unusual tractors you won't believe actually exist. From hot-rodded farm machines packing V8 muscle to futuristic concepts that look like they dropped from orbit. These aren't your grandfather's row crop tractors. These are the mavericks, the oddities, and the engineering experiments that proved farming equipment could be as wild as the farmers who drove them. Number 12, Aker 333 Orchard Tractor. Starting our countdown at number 12 is a machine that proves good things come in tiny packages. The Aker 333 Orchard Tractor from India redefines compact in ways that make American subcompacts look massive. With a 3-cylinder diesel generating 36 horsepower wrapped in a frame narrower than most riding mowers, this machine targets specialty crop operations, where standard tractors simply won't fit. Aker designed the 333 specifically for India's orchards and vineyards, where centuries-old trees crowd together in patterns that predate mechanical farming. The challenge demanded a tractor capable of slipping between trunks, spaced for ox carts rather than modern machinery. Traditional row crop tractors couldn't navigate these tight spaces without damaging valuable trees. Someone needed to think smaller. The 333's dimensions border on absurd. The overall width barely exceeds what 2 men could span with outstretched arms. Height stays low enough to work beneath overhanging branches without snagging. The wheelbase shrinks to dimensions that allow pivot turns in spaces where competitors would need 3-point turns. Every measurement emphasizes one goal: fit where others can't. Power comes from a 3-cylinder diesel, displacing roughly 100 cubic inches. 36 horses might seem modest, but the 8-speed gearbox, 8 forward, 2 reverse, provides enough gear selection to match any orchard condition. The narrow stance that allows passage between trees also raises the center of gravity, demanding careful operation on hillsides. Ground clearance adequate for most terrain prevents high centering on uneven orchard floors. The 3-point hitch accepts implements scaled to the tractor's size. Small rotary tillers prepare soil between tree rows. Compact sprayers treat foliage without oversaturating. Transport boxes carry harvested fruit. Everything designed for the 333 emphasizes specialized capability over universal application. This machine knows its mission and executes perfectly. Today, the 333 remains popular in India's specialty crop regions, where its unusual dimensions solve problems standard tractors can't address. Export models occasionally appear in American orchards, where owners appreciate genuine specialty equipment. The 333 proves that sometimes the most unusual solution becomes the most practical. Number 11, Same Buffalo. Moving up to number 11 is an Italian machine that looks like it escaped from a design student's fever dream. The Same Buffalo appeared during the 1960s, wearing styling so aggressive it made contemporary tractors look timid. With a 6-cylinder diesel generating 100 horsepower housed beneath a hood that looked like a shipping container welded to the frame, this machine confused onlookers while impressing farmers who valued capability over aesthetics. Same. Società Anonima Motori Endotermici built its reputation on robust tractors that Italian farmers trusted for demanding work. The Buffalo arrived as Same's entry into the high-horsepower segment, when agriculture worldwide demanded more muscle. A 6-cylinder diesel promised smooth power delivery. Mechanical transmission provided fundamental gear selection. Hydraulics powered implements. Everything suggested typical Same quality, wrapped in thoroughly atypical sheet metal. That hood remains the Buffalo's most distinctive feature. Massive, squared off, and completely unapologetic, it dominated the front of the tractor like a cast-iron monument to industrial design gone rogue. The styling broke every contemporary convention. Where competitors curved and sculpted, Same simply welded flat panels at right angles. The result looked more like industrial equipment than agricultural machinery, which perhaps was precisely the point. Beneath that extraordinary exterior lived conventional Buffalo engineering. The 6-cylinder diesel delivered adequate power across the operating range. The transmission provided sufficient gears for field and transport work. Hydraulics powered implements with typical Same capability. Operators who got past the styling discovered a competent tractor that worked as intended. The unusual appearance didn't affect functionality. The Buffalo remained rare outside Italy. Same's limited export network meant few reached American shores. European farmers appreciated the capability while debating the aesthetics. Today, Buffalo tractors attract collectors who value unusual design as much as mechanical interest. The styling that seemed so strange in the 60s now appears charmingly distinctive. The Buffalo proves that sometimes the most unusual-looking machines become the most memorable. Number 10. Versatile bidirectional tractor. Breaking into the top 10 is a machine that questions fundamental assumptions about which direction is forward. The versatile bidirectional tractor appeared during the 1980s with a cab that rotates 180 degrees, allowing the operator to drive equally well in either direction. With a 6-cylinder diesel generating between 150 and 250 horsepower, depending on model, this machine solves problems most farmers didn't realize existed. Versatile manufacturing built its reputation on four-wheel drive articulated tractors that dominated Canadian prairie farming. The bidirectional concept emerged from specific operational challenges. Certain implements, balers, forage harvesters, specialized cultivation equipment work best when the operator faces the implement, rather than having it trail behind. Traditional tractors force operators to twist uncomfortably in their seats to monitor rear-mounted equipment. Versatile solution. Make front and back interchangeable. The engineering challenges proved substantial. The cab needed to rotate smoothly on a bearing system robust enough to handle field vibrations and impacts. Controls had to remain intuitive, regardless of which direction constituted forward. The transmission required equal capability in both directions, rather than the token reverse found on conventional tractors. Hydraulics needed to power implements mounted on either end. Every system demanded rethinking fundamental tractor design. The execution impressed. Operators rotated the cab 180 degrees via hydraulic power, transforming front into rear and vice versa. Controls remained logically positioned regardless of orientation. The hydrostatic transmission provided equal performance in both configurations. Implements mounted on quick-attach systems at either end. The versatility the name promised became genuine capability rather than marketing hyperbole. Applications emerged quickly. Custom harvesters appreciated the ability to face windrow weirs and balers directly. Farmers discovered advantages in certain cultivation operations. Municipal operators valued the maneuverability for snow removal and street maintenance. The bidirectional design that seemed gimmicky proved genuinely useful in specific scenarios. Today, Versatile continues offering bidirectional models to customers who value the capability. The unusual design that raised eyebrows initially has become an accepted tool for specialized operations. The bidirectional tractor proves that sometimes the most unusual engineering solutions address real problems conventional thinking can't solve. Number 9. Valtra Ants Concept Tractor. Climbing to position 9 is a machine that looks less like a tractor than a prop from a science fiction film. The Valtra Ants concept tractor, unveiled in 2011, represented the Finnish manufacturer's vision of future farming. With hybrid diesel-electric power generating an estimated 200 horsepower, wrapped in styling that suggested alien technology, this machine pushed boundaries between practical engineering and pure imagination. Valtra collaborated with renowned Finnish designer Mikko Keukas to create something that challenged every assumption about what tractors should look like. The resulting design featured a modular cab that detached completely from the chassis, allowing the power unit to operate autonomously or accept different cab configurations for varying tasks. The streamlined body panels eliminated traditional tractor shapes entirely. Everything screamed future rather than agriculture's conservative present. The hybrid powertrain represented genuine innovation. A diesel engine generated electricity rather than directly powering wheels, feeding electric motors that provided propulsion. The system promised improved fuel efficiency through optimized engine operation and energy recovery during braking. Continuously variable transmission disappeared entirely, as electric motors provided infinite speed control. The modular cab concept pushed boundaries further. Valtra envisioned cabs customized for specific operations, one optimized for fieldwork, another for transport, a third for implements requiring different visibility or control layouts. Robotic features allowed autonomous operation for repetitive tasks, while keeping humans in control for complex decision-making. The Ants blurred lines between conventional equipment and robotic farming platforms. Reality check. The Ants remained a concept vehicle. Valtra never intended production, instead using the project to explore possibilities and generate discussion about agriculture's future. The technologies demonstrated weren't ready for commercial application in 2011, but the conversation Valtra started continues influencing tractor development today. Elements of the Ants' vision appear incrementally as manufacturers gradually incorporate advanced technologies. The Ants represents the unusual category of tractors that never actually farmed, yet influenced the industry profoundly. Its science fiction appearance sparked imaginations, while its underlying technologies highlighted genuine possibilities. The Ants proves that sometimes the most unusual machines are the ones that never leave the showroom floor, yet shape what eventually reaches the field. Number 8. Case IH Quadtrac. Reaching position 8 is a machine that questions why tractors need round rubber. The Case IH Quadtrac arrived during the 1990s, with 4 independent tracks replacing conventional wheels. With a 16-liter diesel generating about 700 horsepower, distributed across 4 track assemblies, this articulated giant delivers traction that wheels simply cannot match in challenging conditions. Case IH developed the Quadtrac, responding to specific challenges facing large-scale farming operations. Wet field conditions turned conventional wheeled tractors into expensive paperweights. Even four-wheel drive machines with duals struggled when soil turned soupy. Tires sank, spun, and compacted soil into concrete hard layers that damaged future crops. Ground pressure from concentrated weight points created problems that persisted seasons after the initial pass. The Quadtrac solution distributed weight across 4 independent track assemblies. Each track spread the tractor's substantial mass over vastly greater surface area than even the largest tires. Ground pressure dropped dramatically. A machine weighing tons pressed on soil with less force per square inch than a man's boot print. The difference between spinning hopelessly and pulling through became a matter of physics, working for rather than against the operator. The engineering challenges proved substantial. Each track assembly required independent suspension to maintain ground contact across uneven terrain. The articulated steering system needed to account for track behavior rather than wheel geometry. Hydraulic systems powered everything from track tensioners to implement controls. The complexity exceeded conventional tractors by orders of magnitude. Case IH bet that capability justified the complications. Farmers discovered the Quadtrac excelled precisely where claimed. Wet field conditions that stranded wheeled tractors barely slowed the Quadtrac. Spring planting proceeded regardless of moisture. Fall harvest continued through weather that would have stopped conventional machines. The ability to work when others couldn't translate it directly into productivity, advantages that justified the substantial purchase price. The unusual tracks attracted attention wherever Quadtracs appeared. Observers accustomed to conventional tractors did double takes seeing machines that moved like tanks through agricultural fields. The distinctive appearance became instantly recognizable. Today, Quadtracs represent Case IH's premium power offerings, with multiple competitors following the 4-track configuration pioneered here. The unusual solution became industry standard for maximum traction applications. Number 7. Big Bud 747. Breaking into the top half at number 7 is a machine that redefines scale. The Big Bud 747, built in 1977, holds the title of largest farm tractor ever constructed, with a 16-cylinder Detroit diesel generating 760 horsepower, wrapped in a frame, stretching over 27 feet long, and tipping scales at 46,000 pounds. This machine makes conventional tractors look like toys. Big Bud Manufacturing in Montana specialized in building custom large-scale tractors for farmers working thousands of acres where standard equipment proved inadequate. The 747 represented the ultimate expression of that philosophy. A cotton farmer in California needed something capable of pulling the widest implements available across vast fields. Big Bud responded with engineering that made competitors look conservative. The numbers defy belief: 27 feet long, 14 feet wide, 14 feet tall. 8 massive tires, each standing nearly 8 feet tall, a fuel tank holding 1,000 gallons for all-day operation. 6-speed transmission routing 760 horses to rubber meeting dirt, weight exceeding 20 tons without implements. Everything about the 747 operated at scales that seemed more industrial than agricultural. The 16-cylinder Detroit diesel, essentially 2 V8 engines mated together, generated power through turbocharging and displacement measured in cubic feet rather than cubic inches. The engine alone weighed thousands of pounds. Cooling systems circulated gallons of coolant through radiator size for locomotives. Fuel consumption measured in gallons per hour rather than hours per gallon. Operating costs alone exceeded what small farmers spent on entire operations. The 747 worked California fields for decades, pulling cultivators, plows, and harrows sized to match its capabilities. Productivity measured in acres per hour rather than per day. The machine's owner discovered that one operator with the 747 accomplished more than multiple conventional tractors and crews. Economics justified the unusual scale. Today, the 747 resides in a museum after decades of service. Big Bud built other large tractors, but nothing matched the 747's audacious scale. The machine represents the extreme end of farming's bigger is better philosophy, carried to logical conclusion. The 747 proves that sometimes the most unusual tractor is simply the biggest anyone ever built. Number 6. Cletrac Model F, Crawler Tractor. Moving to number 6 takes us backward to the 1920s and a machine that chose tracks over wheels when tracks seemed radical. The Cletrac Model F crawler tractor appeared when most farmers still worked behind horses, with a 4-cylinder engine generating 20 horsepower driving steel tracks rather than rubber tires. This compact machine introduced crawler technology to operations that couldn't justify larger industrial models. The Cleveland Tractor Company, Cletrac, pioneered agricultural crawler tractors when the concept remained exotic. Tracked vehicles existed for military and industrial applications, but seemed impractical for farming. Cletrac's engineers recognized that soft soil conditions defeated wheeled tractors regularly. Mud, sand, snow, and marshland turned wheels into anchors. Tracks distributed weight and maintained forward motion where wheels spun uselessly. The Model F brought crawler technology to a compact package farmers could afford. Previous crawlers ran large and expensive, targeting industrial applications with budgets beyond agricultural reality. The Model F sized appropriately for small farms, while delivering the traction advantages that made crawlers valuable. 20 horses might seem modest, but the tracks multiplied effectiveness through superior grip. The design emphasized simplicity appropriate for farmer maintenance. The 4-cylinder engine used conventional ignition and carburation. The track system utilized basic components farmers could repair with standard tools. No exotic technologies required specialized knowledge or expensive parts. Cletrac understood that agricultural equipment succeeded only when operators could maintain it themselves between professional service intervals. Applications emerged where the Model F's unusual configuration excelled. Logging operations valued the ability to work on slopes and soft ground. Rice farmers appreciated performance in muddy paddies. Any operation dealing with conditions that defeated wheels discovered advantages in tracks. The compact size allowed work in areas where larger crawlers couldn't maneuver. The Cletrac Model F established crawler tractors as legitimate agricultural tools rather than industrial oddities. Competitors eventually followed with their own crawler designs. Today, tracks appear on equipment from compact utility tractors to massive combines. The Model F's unusual for its era tracks became mainstream technology. The machine proves that today's radical innovation becomes tomorrow's conventional wisdom. Number 5. Lanz Bulldog Hot Bulb Tractor. Claiming position 5 is a machine that started with a blowtorch and ran on anything flammable. The Lanz Bulldog appeared in Germany during the 1920s and continued production into the 50s, powered by a single-cylinder hot bulb engine generating between 30 and 50 horsepower, depending on model. The starting procedure alone, preheating a cast iron bulb with an open flame, qualified this machine as unusual before it ever turned a wheel. Heinrich Lanz built his company on semi-diesel engines that operated on principles different from conventional diesels or gasoline engines. The hot bulb design featured a large cast iron chamber that required preheating before the engine would run. Operators lit a blowtorch or used kindling and held flame against the bulb for several minutes until metal glowed cherry red. Once hot enough, fuel injected into the chamber ignited from radiant heat rather than spark plugs or conventional diesel compression. The single massive cylinder displaced volumes measured in liters rather than cubic inches. The piston stroke exceeded 2 feet on larger models. Watching that piston lumber up and down resembled a slow-motion jackhammer. Operating speeds barely exceeded 400 revolutions per minute, creating a distinctive thump-pause rhythm that earned the Bulldog name from sound more than appearance. The Bulldog earned reputation for indestructibility and simplicity. The massive flywheel stored enough rotational energy to carry through compression strokes. Few moving parts meant minimal wear points. Farmers maintained Bulldogs with basic tools and blacksmith capabilities. Engines ran decades with minimal service beyond periodic bearing adjustments. The simplicity that made them unusual also made them nearly bulletproof. The smoke, noise, and smell made Bulldogs unmistakable. Blue smoke billowed from the exhaust as fuel burned inefficiently. The thump, thump, thump carried across fields, announcing the Bulldog's presence long before visual confirmation. Operators endured noise levels that would violate modern workplace safety standards. Everything about the Bulldog assaulted senses while getting work done. Today, Bulldogs survive in collections throughout Europe, where enthusiasts value the unusual technology and characteristic sound. Starting procedures remain spectacular. That blowtorch preheat never fails to draw crowds at demonstrations. The Bulldog proves that unusual doesn't mean unsuccessful when reliability and fuel flexibility matter more than refinement. Number 4. International Harvester HT340 Turbine Tractor. Surging into position 4 is a machine that brought jet-age technology to agriculture. The International Harvester HT340 Turbine Tractor appeared in 1961 as IH's experiment with gas turbine power. With a turbine engine generating 80 horsepower through a hydrostatic transmission housed beneath futuristic bodywork that looked like a concept car, this machine represented the bleeding edge of agricultural engineering. International Harvester's engineers believe turbines offered advantages over conventional piston engines. Turbines run smoother with fewer moving parts. Power-to-weight ratios exceed piston engines dramatically. Multi-fuel capability allows operation on virtually any combustible liquid. The technology that powered aircraft and was entering automotive experiments seemed logical for agriculture's increasingly sophisticated machinery. The HT340's appearance suggested spacecraft more than farmland. Streamlined bodywork enclosed the turbine and drivetrain. The operator sat in a futuristic pod that prioritized visibility and ergonomics. Everything about the design screamed modern in an industry where traditional still meant trustworthy. IH wanted attention, and the HT340 delivered that in abundance. The turbine itself proved fascinating to observe. Unlike piston engines that shake and vibrate, the turbine spun smoothly at tens of thousands of revolutions per minute. Exhaust temperatures reached levels that could melt conventional materials. The distinctive whine replaced piston engine clatter. Operating the HT340 meant experiencing technology normally reserved for aircraft. Reality intruded harshly on turbine dreams. Fuel consumption exceeded piston engines dramatically. Turbines sip fuel at highway speeds, but guzzle during variable load agricultural operations. Heat management challenged engineers as exhaust temperatures threatened nearby components. Cost exceeded any reasonable agricultural budget. Reliability proved problematic as turbines demanded maintenance expertise beyond typical farm capabilities. IH built approximately 12 HT340s for demonstration and testing before acknowledging commercial impracticality. The technology that seemed promising proved unsuited for agricultural realities. Farmers needed reliability, fuel economy, and maintainability more than futuristic styling and smooth power delivery. The HT340 taught expensive lessons about matching technology to application. Today, surviving HT340s reside in museums as monuments to engineering ambition exceeding practical limits. The unusual turbine technology that seemed revolutionary proved to be a dead end. The HT340 represents the fascinating failures that advance understanding even when commercial success proves elusive. Sometimes the most unusual machines teach the most valuable lessons. Number 3. John Deere DNE all-wheel drive. Breaking into the metal positions at number 3 is a machine that pioneered four-wheel drive when the concept remained radical. The John Deere DNE all-wheel drive appeared in 1918 as the first all-wheel drive tractor ever built. With a four-cylinder engine generating 15 horsepower, driving all wheels through chain drives and a triangular frame that defied conventional design, this machine represented genuinely revolutionary thinking. Joseph DNE designed the tractor that bore his name while serving as a John Deere board member. DNE recognized that two-wheel drive limited traction unnecessarily. Power delivered only to rear wheels wasted the front wheel's potential grip. An all-wheel drive system could multiply traction without requiring larger, heavier components. The engineering challenge involved routing power forward while maintaining steering capability. DNE's solution employed a triangular frame, unlike any contemporary tractor. The unique geometry allowed chain drives to route power from the central engine to both axles. The front wheels steered despite receiving power, a technical achievement that proved complex with era technology. Every aspect of the design broke from conventional practice, creating a machine that confused onlookers while impressing engineers. The four-cylinder engine displaced modest volumes, but the all-wheel drive system multiplied effectiveness. 15 horses might seem inadequate, but distributing power across 4 driven wheels, rather than 2 created traction advantages, conventional designs couldn't match. Fields that defeated two-wheel drive tractors proved navigable with all-wheel drive engaging. Tragedy struck before the Dane reached production. Joseph Dane died unexpectedly, and John Deere acquired the Waterloo Boy Tractor Company shortly after. Deere's management decided the simpler Waterloo Boy better suited immediate production needs than the complex Dane design. Approximately 100 Dane tractors were built before production ceased. The unusual triangular frame and pioneering all-wheel drive disappeared into history. Today, surviving Dane tractors rank among the rarest and most valuable John Deere machines. Collectors recognize the historical significance of the first all-wheel drive tractor, even though commercial success proved elusive. The Dane's unusual design pioneered concepts that eventually became industry standard decades later. Four-wheel drive now dominates agricultural equipment, validating Dane's vision a century after his innovative machine faded from production. Number 2. Massey Ferguson Black Tractor Special Edition. Claiming runner-up honors is a machine that shocked everyone by not being red. The Massey Ferguson Black Tractor Special Edition, essentially an MF 135 painted entirely black for promotional purposes, challenged fundamental assumptions about what color farm equipment should wear. With a 3-cylinder Perkins diesel generating 45 horsepower wrapped in glossy black paint, rather than Massey's signature red, this machine confused onlookers, while generating publicity exactly as intended. Massey Ferguson built its global recognition on distinctive red paint. Generations of farmers identified red tractors with Massey quality and reliability. The color became branding so powerful that competitors avoided similar shades. Red meant Massey Ferguson as surely as green meant John Deere, or orange meant Alice Chalmers. Changing that seemed like branding suicide. The Black Special Edition emerged from promotional campaigns targeting specific markets or celebrating particular milestones. Massey Ferguson wanted attention, and nothing attracted eyes like breaking established patterns. Black paint on a tractor that should be red created cognitive dissonance impossible to ignore. The unusual color transformed ordinary 135s into conversation pieces that generated word-of-mouth advertising money couldn't buy. The mechanical specifications remained unchanged from standard red 135s. The 3-cylinder Perkins diesel generated 45 horses across the operating range. 6 forward and 2 reverse gears provided adequate selection for varying conditions. Hydraulics-powered implements with typical Massey capability. Every functional aspect remained identical to conventional models. Only the paint distinguished the Black Special Edition. Production numbers remained limited, making black tractors rare compared to standard red models. Massey Ferguson never intended mass production. The Black editions served promotional purposes rather than comprising separate product lines. Limited availability increased desirability as farmers and collectors recognized uniqueness. Today, black Massey Ferguson tractors command premium prices from collectors who value unusual variations. The distinctive paint that seems strange when new now appears collectible and distinctive. The Black Special Edition proves that sometimes the most unusual change involves nothing more than unexpected color. Massey Ferguson demonstrated that established brands could generate excitement by selectively breaking their own rules. Number 1. Ford 8N Funk Conversion. Taking top honors is a machine that proves American farmers never met a small tractor they couldn't overheat, overstress, and overpower. The Ford 8N with Funk Conversion swapped the original 30-horsepower 4-cylinder for a Ford flathead V8 generating 100 horses. With power nearly quadrupled and rear axles designed for modest loads, suddenly transferring muscle that could snap drivelines, these converted tractors became legends of agricultural hot rodding. This wasn't factory engineering. This was farmers saying power limits were merely suggestions. The Ford 8N arrived in 1947 as the most popular farm tractor in American history. Harry Ferguson's 3-point hitch revolutionized implement attachment. The simple 4-cylinder engine proved reliable and maintainable. Everything about the design emphasized practical utility for small and medium farms. But 30 horses left farmers wanting more. especially those trying to pull three-bottom plows or handle heavier work the 8N wasn't designed for. Enter the Funk brothers of Coffeyville, Kansas. Funk Aircraft Company built military training aircraft during World War II using inverted Ford engines. When war production ended, they recognized an opportunity. Farmers with 8Ns wanted more power. Funk knew Ford engines intimately. The solution seemed obvious: convert tractors to larger Ford power plants. Funk developed two conversion kits. The more common used Ford's industrial inline six-cylinder, generating approximately 95 horsepower. The rarer and more audacious employed the flathead Ford V8, making 100 horses or more, essentially tripling the original engine's output. The kits included everything except the engine itself, which customers ordered separately from Ford. Each conversion featured a distinctive cast iron oil pan that served as structural reinforcement, essentially becoming part of the tractor's frame. Installation required mechanical skills, but not exotic tools or facilities. Ford dealerships sometimes performed conversions on new tractors. Though Ford officially disapproved and voided warranties on converted machines, many farmers handled the swap themselves, sending their tired four cylinders back to Ford in the same crate the conversion kit arrived in. Ford then sold those engines as industrial replacements, maintaining some profit despite losing control of the modification. The results both thrilled and terrified. 100 horsepower transformed the modest 8N into a completely different animal. Tractors that struggled with two bottom plows now pulled three bottom units with power to spare. Productivity jumped dramatically. Farmers discovered they could accomplish more work faster than competitors running standard equipment. The Funk conversion delivered genuine competitive advantage. The problems proved equally dramatic. Rear axles designed for 30 horses now carried 100. Transmissions engineered for modest loads faced triple the stress. Tires designed for gentle power delivery spun violently under V8 torque. The entire drivetrain operated beyond design limits continuously. Traction became the limiting factor. Converted 8Ns spun all four wheels simultaneously rather than moving forward when operators got aggressive with the throttle. The power exceeded the rubber's ability to transfer it to soil. Control challenges emerged quickly. The original steering geometry and brake system, sized for a 30-horse tractor, struggled controlling 100 horses' enthusiasm. Operators discovered that throttle inputs required restraint. Too much acceleration snapped implements sideways or broke hitch components. Everything demanded careful operation because the machine now possessed power to destroy itself if mishandled. Funk sold conversion kits for approximately 5 years before production ended around 1953. Estimates suggest around 5,000 tractors received the six-cylinder conversion. The V8 Funk conversions numbered far fewer, perhaps only 100 to 200 total. A factory fire destroyed production records, leaving exact numbers uncertain. Ford's introduction of more powerful factory tractors like the Golden Jubilee reduced demand for conversions by offering increased power with factory support. The unusual nature of Funk conversions extended beyond the engine swap. Ford actively discouraged the modifications, sending memos to dealers threatening to void warranties on converted machines. Yet demand proved strong enough that dealers ignored corporate directives and performed conversions anyway. Farmers wanted power more than warranties. The underground nature of the modification, unauthorized by the manufacturer yet performed by dealers, created a peculiar dynamic in automotive history. Today, original Funk converted 8Ns command premium prices from collectors. Rough examples sell for multiple times what standard 8Ns bring. Restored Funk tractors, especially rare V8 models, fetch prices that would buy several standard vintage Ford tractors. The unusual hot rod history attracts collectors who value both mechanical interest and agricultural heritage. Modern reproduction conversion kits allow enthusiasts to create their own Funk-style builds, continuing the tradition of overpowering modest tractors for no reason except because it's possible. The Funk conversion represents grassroots American engineering at its finest. Farmers identified a problem: insufficient power. They found a solution: bigger engine. They implemented it despite manufacturer disapproval. They accepted the consequences of stressing components beyond design limits. Everything about the Funk conversion embodies the can-do attitude that defined mid-century American agriculture. Rules existed to be bent. Limits existed to be exceeded. If 30 horses weren't enough, install 100 and deal with the results. The unusual aspect extends beyond the modification itself. These conversions persisted through decades when most home-built hot rods failed. Original Funk tractors still work fields today, testament to robust engineering in both the base 8N design and the Funk components. The fact that transmissions and axles survived triple the design loads speaks to Ford's overbuilding more than any safety margin conscious planning. The Funk conversion became a cultural touchstone in American farming. Every old-timer remembers hearing about or seeing a Funked 8N. Stories circulated about their power and the trouble they caused. The tractors represented rebellion against limitations. If the factory said 30 horses, farmers demanded 100. That spirit of hot-rodding farm equipment lives on in modified pulling tractors and home-built specials. But the Funk conversion pioneered the concept when tractors were meant to be stock and sensible. From jet turbines to blowtorch starters, from 4 tracks to rotating cabs, these 12 machines prove agricultural engineering never suffered from lack of imagination. Some concepts proved brilliant, others failed spectacularly. A few pioneered technologies that became industry standard decades later. But every single one challenged assumptions about what tractors could be. They represent the mavericks, the experiments, and the crazy ideas that occasionally worked. Which of these unusual machines would you want in your barn? Drop your answer in the comments. And if you love stories about the wildest iron ever to turn a furrow, hit subscribe for more tales from farming's most unusual corners.